11A deals with the RMS error for a regression line. So number 2, look at figure 1, then say whether each statement is true or false. So this is back on page 181. E is above average in weight. What is the average in weight? 180, and E appears to be below that, 170 something maybe. So false. E is above average in weight for men of his height. True, because he is above the regression line. The average weight for that column is the regression line, and we are above the regression line, so yes, above average in weight for that particular height. Okay, number 4. Below are 3 scatter diagrams. The regression line has been drawn across each one by eye. In each case, guess where the RMS error is 0.2, 1, or 5? Well, that's easy. If the RMS error is 0.2, the graph would have to be A, B, or C? A. Because the RMS error acts like the standard deviation of the regression line. So if I go up 0.2 and down 0.2 and draw those 2 parallel lines, I should capture 68% of the population. Okay, for B, is it going to be 1 or 5? 1. But wait a minute, it looks more spread out than C. C uses a larger y-axis. So even though B looks more spread out, you have to look at the scale. And the scale appears, if we went up 1 and down 1 and drew those 2 lines, we would capture about 68% of the people. So C would be 5. So they wanted you to pay attention to how big the Y values were. Number 5. A regression line for predicting income has an RMS error of $2,000. It predicts somebody's income at $20,000 as $20,000. This is likely to be right, give or take a few $100s, a few $1,000s, $10,000 or $20,000. A few thousand, because the RMS error is 2,000. So we would expect to be off by about $2,000 when we guess. Okay, 6. An admissions office is trying to choose between 2 methods of predicting first-year scores. One method has an RMS error of 12, while the other has an RMS error of 7. Other things being equal, which should he choose? The error of 7, why? Okay. Overall, you would be more likely to be around that the first-year scores. Okay, it's like having a smaller SD. Okay. 7. A regression line for predicting scores has an RMS error of 8 points. About 60%, 68% of the time, the predictions will be right to within 8 points. And I want to remind you that that 8 points is different for every column. So if I have my football and my regression line that cuts the columns in half, the RMS error is the same height, but it's based on the regression line. So here we would go up 8, and here we would also go up 8, and up 8, and down 8. And that should capture 68% of the people, just like one SD of a normal curve will capture 68% of the people. What if I go up and capture 95% of the people? How far do I have to go? 16 points, about 16 points. Okay? And hopefully you recognize how we're building this idea from SD back when we were doing 1 variable to RMS error for 2 variable, and we're going to keep doing this same pattern in just a different format over and over and over. And number 8. The scatter diagram on the next page shows incomes for a sample of 168 working couples in Louisiana. Summary statistics are as follows. If you predict wife's income at $28,000, ignoring husband's income, your RMS error will be, how do we do that? Well, let me throw this up. Oh, seriously? Let's see. way. It'll be faster. Okay. So husband's income is $45,000 with an SD of $25,000. Wife's income is $28,000 with an SD of $20,000. And A asks, if you predict wife's income at $28,000, ignoring husband's income, your RMS error will be what? $20,000. How come? That's the SD of the Y value, so I'm only using this. I'm not even paying attention to the X values. And the RMS error is the SD. Okay? B, all the predictions are on one of the lines of the diagram. Which one? Is it the horizontal line, or the slanted line, or the vertical line? The horizontal line. How come? Because that is the line where the wife's income is $28,000. Right? So we're ignoring the X values entirely. And we're just looking at that horizontal line at 28,000. Okay? All right.